Let me ask you, are you ready to dive into the world of convolutional neural networks? We've captured the same model at 4 different stages of training, so you can see how it gradually improves with each epoch, or in other words, each time it trains. But before we dive in, let's talk about the MNIST dataset. This is the dataset that the model has been trained on. With 60,000 images, it's pretty easy to train the model. With one epoch, you can get the model to above 80% in accuracy. That's exactly why we've cut down the training set to 10,000 images, so you can witness the model's progress firsthand. In just one epoch, the untrained model's accuracy jumps from a mere 6.76% to an impressive 64.69%. In case you're not familiar with the term, an epoch is simply the number of times the training set is passed through the network and back propagated. After 5 epochs, the model's accuracy soars to 87.44%, and after 15 epochs, it reaches an astonishing 92.74%. Impressive, isn't it? But enough talking, let's dive in. First things first, the first convolutional layer consists of 2 5x5 kernels. It uses a stride of 1 and ReLU as the activation function. By running the convolution and visually analyzing the output, we notice that more pixels get activated as the accuracy increases. In some sense, it is easier to see that we are working with the number 7 by looking at the first activation layer in the untrained model than it is by looking at the same activation layer in the model with 92.74% accuracy. Moving on and performing max pooling on the activation layer, we see that the activated neurons get amplified. As the accuracy increases, more neurons, or pixels, get activated. This is especially true for the second activation channel. Now, let's move on. For the second convolutional layer, we use 4 3x3 kernels with the stride of 1 and sigmoid as the activation function. The kernels have 2 channels to match the activations from the previous layer. Running the convolution, we see that this time around the patterns have flipped. I found this quite interesting. As the accuracy increases, notice how the activated neurons decrease. The untrained model has activated neurons all over the place. These slowly gets removed as the accuracy improves. The model is kind of removing the noise. In addition, for the most accurate model, it is impossible to tell that we started with the number 7. Or maybe you see it, but I don't. This is not the case for the latter. Anyways, let's move on. As mentioned earlier, the max pooling layer sort of amplifies the activated neurons. It now becomes much clearer that fewer neurons get activated as the model improves in accuracy. Notice how almost all neurons get activated in the untrained model? Now, let's flatten the channels and move on to the final layer. The output layer is pretty straightforward. We notice that the untrained model is the only one that gets the predictions wrong. By looking at the activated numbers, we also see that it is unsure. Although 2 is the most activated, we do notice that 0, 4 and 6 get activated. Anyways, thank you for watching. Please make sure to like, comment and subscribe if you got some value out of this video.